Hey YouTube, welcome to part 20. In this video we're going to talk about how to use our framework for parallel testing. And as I mentioned in the video before the previous one, that you can use the framework that we have right now to do parallel testing already. And let me just elaborate on that more. So every time we trigger our framework with Java dash jar and the path to our jar, basically this starts a new JVM. And then the JVM executes the code that we have written, right? So, and that code is such that goes out and looks at what devices are connected and whether those devices have unlocked that APK installed, and if they don't, then we're going to use that device for testing. So if you start two of these JVMs at the same time, then you're going to have issues. Because both of them are going to go out, both of them are going to check what devices are connected, both of them are going to check that whether or not that first device, they both going to get that one same device that's connected, or if you have 100 devices connected, they still going to have the list will be returned in the same order to them. So they both going to start with checking from index 0. Right, so in this case it's going to be this device. So both of those JVMs are going to start checking whether this device has unlocked that APK installed, and both of them are going to get the same answer, no it doesn't. So both of them are going to attempt to use this device to create the driver, and there's going to be a collision and it's going to be bad. But you can overcome that by starting one JVM, waiting for that JVM to initialize, and then once it's initialized, what I mean by initialize it, once it's created the driver on that device, then you can start the second JVM, and then the second JVM will skip the device that was used by the first JVM because it's going to see that unlock that APK already installed on the device, so it's going to move on to the next one, and so on. So you can start as many JVMs as you want, as many JVMs as your server can support, because remember, each JVM will require resources to run. So there probably will be hardware limitations for how many JVMs you can have, and the more tests you have, the more resources it's gonna eat up. The code that we have right now, you can probably run a lot of JVMs. I don't know, I don't want to put a number to it, but it's pretty large. You're probably not going to have that many devices in your lab. Um, so, um, right, so what we want to do in this video is we want to add support so that we don't have to wait between like between starting JVMs. We don't want to do that manually. We want our framework to do that for us, right? We just want to say, hey, start this many test cycles, like 3 test cycles, right? We want to test on 3 different devices. So start 3 test cycles, and that's it. We're done. And then we want our framework to take care of everything else. We want a framework to communicate between the JVMs, saying, hey, I'm starting test on this device, so whoever else is out there, if you're running after me, do not use this device, and so on. So let's take a look. I already have created the code. I decided not to do this on video because that would make for a very long video. It's because this video is probably going to be already pretty long, even just me explaining the code. And if I was writing it and explaining it at the same time, this would be very, very drawn out video. So first thing that we need to do, we need to make sure that we have a new dependency in and build.gradle file. We want to make sure we have JSON simple in our project. So you can get that from the Maven repository. If you go in and you just type JSON, if you type JSON in here, you have one from Google here. So just click on it, click this, and then you have your Gradle thing here. Just copy this compile line and paste it in to your build.gradle file in your project, and then wait for Maven to build or to rebuild the project, and then you can reference it later in your classes. And now let's take a look at some of the classes that I have created. Or, well, I have created one class. Over here you can see resources. This is a new class that relies on JSON simple. By the way, when you are going to be implementing this, if you have some other JSON libraries in your project, make sure that you import org.json.simple. You may have org.json. That is not going to work. You're going to have errors if you use org.json, .json object or whatever. Make sure you have org.json.simple. So in this resources class, basically this resources class represents our resources folder. Okay, I just created one method that returns JSON object representation of this Q file, and over here I have my path. This path is dynamic. It's going to change depending on where I start my program. If I started from idea, it's going to have one path. If I started from a jar, it's going to have another path. If I started from Jenkins, it's going to have another path. So by implementing this new method in Server Manager get working dir, I'm able to bypass it. And I'm gonna say right now that if you are going to be adding more files into your resources, make sure you reference them. Your reference starts with Server Manager get working dir, so you don't have any pathing issues later on down the road. Okay, so basically one more thing, and that is Server Manager get working dir basically will return the location of the project, so the demo. Inside the demo, that's where you start appending the path from, right? So you can see over here that, let me see. So we have our demo, and then I start navigating from source, right? So this is where you can start navigating from. You can reference Gradle, you can reference whatever from here after you get the working dir. Hope that makes sense. Alright, so let's take a look what else I have done here. Right, so now that we reference a q.json file, we also need to make sure that we have that file in our resources. Otherwise, we're going to get an exception that this file does not exist. So basically, go ahead and just right click on the resources, say new file, and add a new file, name it q.json, and make sure it's empty JSON. Just put the two brackets like this in here, and that way you have an empty JSON initialized. So when the JSON object is returned, it's not going to give you an exception. It's going to return a JSON, but it's not going to contain any keys. So everything is going to work as expected. And let's see what else we got. So oh yeah, inside of Server Manager, besides the get working dir method, we have another two methods that I have put in here. Basically, I put the write method, and this writes the new queue. Well, it can really write anything, but we're using it to write our updated queue to the queue.json file. And I thought, if you have write method, why not have a read method? So I just put in the read method in here as well. So basically, you can use this two methods to read from a file, and you can just put the file path first, and then if you want to write something to it, just put the content in. If you want to read something from it, just put the path of the file in, and it will return a string representation of that file. Let's see what else we have. I think that's it for this class here. No other changes, just these three methods. And then all of the other stuff is happening. Oh, there's one more thing actually in timer. I did put one more method in timer, and this is really simple. It just calculates the difference between uh, start timestamp and finish timestamp, and returns an integer representing how many seconds have passed since you started something. So at this point, we can go into a driver manager because that's where the magic happens. So let's go down here. We have 4 new methods in the driver manager. We have queueUp. We have another method that tells us whether or not it's okay to use the device that we are attempting to use. And then we have method that calculates the grace period. Grace period basically means how much time you want to spend before proceeding. And then we have method to leave queue. So if you queued up, we want to make sure we leave the queue after we're done. So that's what this method does. So queueUp and leave queue are pretty self-explanatory. When we decided to create a driver for a particular device, we queue up that device into the queue.json. So then the next JVM that's attempting to look at which devices to use can then check the queue and see if that device is already being used by another framework, and if it is, then it's just gonna skip it. So that's what we the check for that is in useDevice. useDevice basically tells us if the device that we are attempting to put into available devices is already being used or not. If it's not being used, then useDevices will return boolean true, and if it returns true, then we're going to put that device into available devices. And then in our create driver method over here, we have our we're referencing get available devices, and then we go device by device, and then we're double checking that it's okay to use that device. By double checking, we eliminating any possible possibilities for 2 different JVMs to try to initialize the same device completely. Um, so that's why we use it in 2 places here. And we use it right before we actually attempting to create the driver. And then over here you can see that we also use queueUp method, which basically after all of the checks are passed, and now we are completely sure that this device is okay to use, then we're gonna queue it up. So the next JVM is not gonna use it. And then we're gonna also check the grace period, and the grace period basically means, oh, let's go take a look at the code a little bit here. So grace period means if we did not queue first, I put comments here which explain the logic. So if we did not queue first, we need to wait for the other device to initialize the driver, so there is no collision. So this is what we check here. So we queued at certain time and they queued at this time, and if we queued after them, then we check the difference. If that difference is less than 50 seconds, so if they queued before us and they fall into the 50-second window, then we need to give them some time to initialize, so there is no collision. And the time is 15 seconds for each device that queued before us. And then at the end here we do thread.sleep, which I'm not a fan of, but in this case I guess it works. So we do thread.sleep, and here the default value is 0, by the way, so if no one queued before us, then we are not going to wait much at all. So let's see, so that's the grace period. And let's go back to the create driver method here. So queued up, waited if we had to wait, and then we created the service, we initialized the driver, and then we left the queue. And so now if we run, I can't actually show it to you because I only have one device, but I can show it to you with one device, I guess, how it's gonna work. I have it connected. I'm actually not going to like display the screen, but I will just run the runner here, and you can just see the output of how the queue works. So there we go. We are queuing up this device because it's good to use for testing, and then this is how the queue then looks. And if we had more devices, they would be displayed in here as well if we were initializing them at the same time. So now if we ran two JVM instances, the second one would see that this device was already queued and it was queued at this time, so it's already being initialized by another JVM, so we're gonna skip it. And then if we were using my current setup, I don't have any more devices, so then it would say no more available devices, waiting, right? Because we have a loop for getting available devices. Here we have a loop, I think. Let's see. Oh, maybe we don't. Actually, no, we don't have a loop, so it doesn't wait. I thought there was a while loop. I actually have a while loop on my live framework, so if there are if it can't find any devices, it will just keep querying until it finds one. But in this case, it will just stop trying. And here we see that some tests ran and they passed. Everything is working. So that's it, guys, for this video. You can find this code. I'm gonna publish it to GitHub right now, so you can get it on GitHub. If you did not understand something, shoot me a message. I'll try to answer it. But hopefully you did understand it. It is a little bit confusing. It might be confusing, but once you look at the code and maybe try to play with it yourself, see what works for you, what doesn't, you should be able to kind of figure it out pretty easily. But yeah, thank you guys for watching. That's it for the video. Make sure to share, subscribe if you haven't liked the video, and if you share the video, it helps me a lot, guys. So thanks so much. You can find this code on GitHub, and in the next video we're gonna take a look at how to create some reports and how to send those reports to people through email. And those are going to be very basic reports, just how many tests ran, how many failed, and like a list of tests with the with the status, pass or fail, and then why. So that's in the next video. Thank you guys for watching. Take care.